Diagnostics is no more than taking a group of symptoms that we already know about the NOVA and putting them with our grafting software on the dyno and then identifying the components that may be giving us the issue. For the condition that we call porpoising, we're going to take a look at our test graph from the 150 to the 154 seconds. What we will do is we will look at the torque, the engine RPM, manifold vacuum, and wideband. We will finish up by looking at what the gas analyzer tells us to give you a better indication of the secrets of the gas analyzer and the ability to help you resolve the problem. To start the diagnostics, we're going to look at the first second of the application of the clutch. So from the 150th to the 151st second, we're looking at the torque that is being generated. Now this torque is measured at the rear wheels, but it is representative of what the engine is putting out. The RPM that we are seeing is engine RPM. Vacuum is manifold vacuum, base of the carburetor. Air fuel on wideband is at the tailpipe. Wheel speed is the actual roll mile an hour. Throttle position is no more than a potentiometer added to the end of the throttle cable, which gives us the percent opening of the throttle plates. We know that the response of the torque is directly related to the engine RPM because of gear ratio. Now we'll take a look at manifold vacuum and CO. Manifold vacuum is going to give us the load that the engine sees. The CO gives us the amount of fuel in which the engine is receiving. This number is far more accurate than using an air fuel because the air fuel is destroyed by the amount of oxygen and hydrocarbon that's sitting within the exhaust, thus rendering it inaccurate. The reason that the CO is a real number, that is the actual amount of fuel that was combusted within that chamber, delivering the power that it takes to drive the vehicle. We also have a condition that's occurring which is called acceleration of the vehicle. So we will need an increase in the amount of fuel to help us drive more torque. To be able to achieve this additional torque, we will also need to move the throttle plate, increase the amount of air that is going into the engine so that we also will generate a higher combustion pressure. On a carbureted car, we use a position or circuit called the slot. What that is the idle to main jet transition circuit. This circuit is governed by air bleeds. The air bleeds assist us in getting the correct air-fuel mixture for this transition. Because we are running lean during this transitional period, we will need to decrease the air bleed that is in the main body that is on the outer walls of the car. The decrease in this air bleed side will increase the draw on the fuel, causing more fuel to be supplied through the slot into the base of the carburetor. This increase in the fuel is going to be reflected in hydrocarbon, not CO, because CO is the effect of the burn. The hydrocarbon is the amount of fuel being metered into the engine. Because of the overlap, we are going to have more hydrocarbon in the exhaust. This is the total of the wasted fuel that was unburnt going through the engine. The combination of CO and hydrocarbon is the total fuel that the carburetor was metering. When we talk about burn efficiency, now we need to take a look at CO2 and torque. CO2 gives us the efficiency coming out of the tailpipe. Torque is the work that's done. Now let's take a look at work that has been done. If we follow the graph and we take the CO2 and torque and follow that out to the 150 to 157 seconds, you can see the increase in the CO2. You also see the torque smoothing on out. since the torque that we are measuring seems to be on average of what it takes to be able to launch the Nova, we know that if we have torque at 30 to 40 pounds, we will have more than enough to drive the vehicle. We also know that the CO should be at about 2 to 3%. This will give us a target on the bleed of or changes in the air bleeds within the system,